That's good. Moving right along here. We're on 153 of 190. We're probably deep into an hour. So here is an inequality. We're going to do it. It's in slope-intercept form. It has a y-intercept of -4. I would make a dot, but because it's greater than and not equal to, that border is going to be an open circle on my y-intercept. So I do an open circle. I'm going to use my slope, which is 1, which means I go up 1, right 1, open circle, up 1, right 1, open circle. So along that line, you'll see people do solid lines. I like dotted because it's non-including, or maybe I like the, no, yeah, dotted. A lot of people will do that. Now we have to understand this is the border between true and false. So I know my border is not included because it doesn't have an equal sign. So this border is going to give me all false values. And then one side's going to be true, the other side's going to be false. I don't know which side right now. I can't necessarily look here. I wouldn't advise students. I would pick a point. And the easiest point to test is 0, 0. So I'm going to plug in 0 into that equation. And 0, and is that true or false? 0 greater than -4. Yeah, that's true. So that point right here is true, so I know all the points on this side are true, and I know all the points on the other side are false. So you always shade the true side so it looks like that. That's how you do it. Oh, it is dotted. Open. I think my new thing is the open circle. I would never, no, that looks good. Y-intercept, this time it's an equal sign, so it's going to be a closed circle on -3. I'm going to use my slope, which is, hey, my slope is -1/3. So I need to understand it's either -1/3 or 1/3, not -1 over -3. There's only one negative, so make sure there's only one. So I'm going to go down 1, right 3, or I'm going to go up 1, left 3. This is going to be a solid line, because it's included. The border is included because it's equal to. So we put arrows, and then we're going to test 0, 0 again. Test 0, 0. So we'll plug in 0 is less than or equal to -1/3 times 0 minus 3. Is 0 less than or equal to -3? That would be false. So this point is false. So all the points on this are false. Do we shade false? No, we shade true. So we're going to shade down this time. And we would just do that. So that is going to be our equation, or that's our graph. Now we have systems. Systems just means that we do it twice. I'm going to, let's color this one. Let's do this. Let's do the highlighter. So I'm going to do this in green. That in green, pen, green. So y-intercept of 4. Oh, equals, good. So this is systems with equals. So I'm going to do that. I'm going to go up 1, right 3, make a dot, and then I'm off, so I'll go down 1, left 3. We'll make let's make that green. So we will graph that. That was pretty good. We'll put arrows, and now we'll do the other one in blue. Let's do that graph in blue. And that has a y-intercept of -1 and a slope of down 1, 2, 3, 4, right 1, 2, 3, or up 1, 2, 3, 4, left 1, 2, 3. It's nice to see that it shares that. Let's change the color to blue, and let's connect those dots. That wasn't the best connecting of dots. That's not bad. And blue, we'll put arrows, and so where it intersects is going to be the solution. Is going to be the value that they both share as a true value, because these are all the solutions to the blue. These are all the solutions to the green, and they want when we want to solve a system, what point do they share? They share that point. So I'm going to write that location. That location is -3, 3. So that would be the solution to the system of equations. You can draw it, but typically you list the point. Let's do, again, let's get our highlighter. Let's do the top one in green, the blue one in blue, bottom one in blue. So I have a y-intercept of 1. Let's make a dot. I have a slope of -1. We're going to make 2 dots there. Let's draw our line, make it green. Let's connect those. That's nice. I'm going to be a stickler for detail. I'm going to put arrows on my line to show that there are an infinite number of solutions. Now we're going to do this -2, slope of up 1, left, ooh, or down 1, right 4. Ooh, see, if I went that way, it would have gone over here. And that would have been moving away from my graph. So I'll go down 1, right 4, and I get onto that intersecting point. So that's a little important trick. Oh, wow, I am so good at drawing, connecting dots on this thing. Kinda. Arrows, arrows, they share this point right there. So let's list that point. That point is going to be 4, -3 would be the solution to that system. Solve each system by substitution. So we have to substitute. We're going to isolate one of these two equations for a variable. This is going to be the easiest one. We're going to isolate for x. So we're going to take that equation. We're going to isolate x. We get x equals -5y plus 20. And now we're going to substitute it into this bottom equation. -3x minus 5y equals -20. So we are going to take this equation and substitute it in. We're going to substitute it in for where we see an x. So where we see an x, stop it. Where we see an x, we're going to take this equation and substitute it. So instead of having -3 times x, we're going to take this value, -5y plus 20, and we put it in for x. Minus 5y equals -20. Now we're going to simplify. 15y minus 60 minus 5y equals -20. Simplify on the same side, which is 10y. We're going to add 60 to both sides to get the constants on the other side. That gives us 40. Divide by 10, divide by 10. Y value is 4. So that's my y value of my intersecting point. So I'm going to take one of these. I'll take this equation because I need to find the x value. So this is kind of set up for me to find out what it is. That's -20 plus 20. X equals 0. We're going to take the x value and the y value. This is the solution to the system. So nicely done. We're going to keep going. We're going to power through. This is going to be a 2-hour video doing part 3. Solve each system by substitution. We're going to take this one. That one looks the easiest. 7x plus y equals 7. We're going to subtract 7x. We get y equals -7x plus 7. We're going to take that value and we're going to substitute it in where we see a y in the other equation. We can't substitute it back into the original equation. We always have to substitute it back into the other equation. So where we saw y, we're going to write -7x plus 7 equals -7. That's -7x. We're going to distribute that -8 which is positive 56x plus 56 equals negative 7. Like terms gives me 49x. Let's minus the 56 to both sides. 49 equals negative 63. Yeah, are we getting a fraction? Are we getting a fraction here? Did I do it wrong? That's definitely 49. That's negative 7. That's positive 56. That is negative 56, Mr. Mac. That is a negative. Sorry, you saw that. Made a mistake. So we're going to add, and that gives us something much better. So again, notice I had a fraction. That was weird. So that's 49, divide by 49, divide by 49. X value equals 1. Let's substitute it back in. We get y equals negative 7 plus 7. Y equals 0. So I know my intersecting point, or the solution that they share, is 1, 0. But it's saying when you get a weird fraction, you might want to go back and check your work. Oftentimes, you're wrong. Solve each by elimination. So first thing we have to make sure is that our variables and our constants are aligned on the same equal. So this is ax plus by equals c, ax plus by equals c. So that's standard form, standard form. We're going to look to cancel these. None of these cancel at the moment. I can either multiply the denominator by negative 5, which would get rid of the x's, or I can multiply the numerator by negative 2, which would cancel out the y's. I'm going to multiply by negative 5. So this equation doesn't change. 5x plus y equals negative 13. I'm going to multiply everything, even this, everything. So that gives me negative 5x. That gives me negative 10y equals negative 5. Now we see that the x's cancel, and this gives me negative 9y. This gives me negative 18. Divide by negative 9, and we get y equals a positive 2. We pick an equation to plug it back into. So I'm going to use the bottom one because that looks somewhat nice. X plus 2 times 2. I substituted it back in for y. X plus 4 equals 1, minus 4, minus 4. X equals negative 3. So my solution to my system is negative 3, comma 2. That's good. Solve each system by elimination. So which one, they're in the same format. I can just multiply this by 6. So again, we don't change the top equation. We're going to multiply everything by positive 6. That gives me negative 6x. That gives me a very large positive number. 6 times 8 is 48. 108 equals 30. Oh, that's going to be, that cancels. This gives me 99. Y equals 0. Divide by 99. I get y equals 0. Let's plug it back into any of the two equations. I'm going to pick this one because the y is 0. So 18 times 0 equals 5. Negative x plus 0 equals 5. Negative x equals 5. Let's divide by negative 1 to isolate my x is negative 5. So my point is negative 5, 0. Negative 5, 0. Yep, 60. 160, Mr. Mac. Yeah, I know. We're getting there. Sketch the solution of each systems of inequality. So here is very like systems, but this is an inequality. So I'm going to do that one in green, that one in blue. And we will see where they share the intersection. There's going to be a lot of points. So 3, open circle. That's a horrible open circle. Open circle because it is not equal to. My slope is -5. 1, 2, 3, 4, 5. Right, 1 open circle. I can't do any more. I'm going to make this a dotted line because it's showing that the boundary is false or not including. I'm going to make it green. And so we do this, and now I have to shade. It's almost like the inequality when you had 1, you're just going to do it twice. So I'm going to test, I'm going to write this, I'm going to test 0, 0 for the green equation, 0 less than 3, because that 0 will cancel this. Is 0 less, that's true. So I'm going to do baby hairs going this way because that is where all the trues are. Now I'm going to do blue. -3, open circle, slope of 1. Oh, I see where it intersects. And then I'm going to do a dotted line again. Good. This time it's going to be blue going in that direction. I'm going to put some arrows for specificity. I'm going to test 0, 0 for the blue equation. So 0 greater than -3, that's false. No, 0 is greater than 3. Sorry. That's true. 0 is greater than 3, a -3. So that's going to shade in this direction towards that point. And now we look for the true. This is true for blue, but false for green. This is false for blue and false for green. This is false for blue, but true for green. And this is true for green and for blue. So we double shade this area. That's how we do it, kids. That's all we do. Let's do this equation in green, this equation in blue. We're going to do it a little bit faster. -2, closed circle. Slope is 5/3. 1, 2, 3, 4, 5. 1, 2, 3. Let's connect the dots. Let's make my line green. Oh, it's not dotted. Got to change that. Change you to solid. And let's put arrows. Arrows. Let's do blue. Oh, no, we're going to shade, test. 0, 0. So is 0 less than or equal to -2? That's false. So this is false, so I'm going to shade in this side. Those are all the true values for that equation. 2, close, oh, no, open circle. Paying attention, open circle. Slope is up 1, right, 1, 2, 3. That's an open circle. Down 1, 2, 1, 2, 3. Let's do dotted. Now we're back to dotted. We're back to blue color. Oh, that was nice that they did my blue. Oh, that was weird. Oh, I did dotted line. Instead of, that would be kind of fun, but I'm going to reverse that because I want a line that is dotted and is blue and is blue. There you go. That's a nice, perfect arrows. Let's test 0, 0. 0, 0 is going to be 0 greater than 2. That's also false. So that's false, so we're going to go on the other side. And do we see where they're both true? Right here. And you need those dotted lines and stuff like that. Yep, that looks good. My hand is cramping. Functions, love functions. Functions are so good. So it says, a lot of kids think, oh, g of 6. No, that g of x means g of -6. That means my x value is -6, and I'm going to plug it into that equation. So I want to find when x equals -6. So I'm going to plug in -6 for x and simplify. So g of -6 equals -24 minus 1. So g of -6 equals -25. That's how we notate. So h of 2 means I'm going to plug in 2 for a, h of a, to 2 minus 1. So h of 2 equals 4 minus 1. H of 2 equals 3. Yeah, those are so fun. So much fun. Find f of 1. So f of 1, when x is 1, is 2 times 2 to the first. So f of 1 equals 2 times 2, because 2 to the first is just 2. So we get f of 1 equals 4. P of 2 for t, so negative 3 times the absolute value of 2 plus 1. P of 2 equals negative 3 times the absolute value of 3. Let's take the absolute value of 3, which is 3, and we were multiplying, so that equals negative 9. We're getting there. Okay, maybe it's going to be an hour and a half. I think that says negative n. Negative n. So we're going to plug in negative n for n. So g of negative n means we're going to plug in a negative n for our n. So g of negative n equals negative 3n plus 1. And that would be our solution, negative 3n plus 1. We're going to plug in negative 1 minus n. So h of negative 1 minus n. It pains me not to write it in standard form. We're going to plug that in for the n. So negative 1 minus n goes in for it, plus 2. So h of negative 1 minus n equals, we'll distribute, negative 2 minus 2n plus 2. We can simplify like terms. Two constants, so h of negative 1 minus n equals negative 2n. Nice and easy. Nice and easy. Am I at the bottom of the page yet? Oh, so close. That's all we have left. All right, so we got to simplify this, and then do the addition. So we're going to find g of negative 10. We're going to look in the g formula, and we're going to plug in negative 10 for our x. So g of negative 10 is going to equal negative 5. So we'll substitute that in, negative 5 plus, now we're going to find f of negative 10. And we're going to plug it into the f equation, which is the opposite of negative 10 plus 1. F of negative 10 equals 10 plus 1. F of negative 10 equals 11. So we'll plug that in for that. Negative 5 plus 11 gives me 6. So 169 should be 6, which it is. So again, find f of negative 5. F of negative 5, we're going to plug in negative 5 in for x in the f equation, which gives me negative 15 plus 5, which is negative 10. So find f of negative 5, which is negative 10 plus, now we're going to have to find the g of negative 5 into the g equation. Oh, baby. All right, so let's move you down here for a second, because this has got a little work to do. So this is negative. It's the opposite of x to the third. That exponent 3 has a base of x, not the negative. That negative is outside of the x. And my x value that I'm plugging in for g is negative 5. So it looks like this. Minus 3, Chewbacca, negative 5. I guess that's the downfall of not being in my classroom anymore, is no more. I'm going to have to do the noise. So we're going to do the exponent, negative 5 to the third. This negative comes down, and then we're going to simplify this, which is negative 125. Negative 5 squared is positive 25. So that goes there. And negative is positive. That's positive 125 5 minus 75 plus 5. That's 130 minus 75, which is my brain. 130, 75 minus 2, 5, 7 from 10 is 5, 55, 5. Yeah, so that's 55. So plus 55, which gives us 45. So 170. 170 is 45, yes. These are fun. I mean, h of 10, it is kind of cool. h, 3 times 10 plus 1. 30 plus 1 is 31. So we have 31 minus, we can do g of 10, which equals the opposite of 10 squared. Now the negative is outside there, so we're going to square the 10 squared, because that's minus 100 plus 1 is negative 99. So we get minus 68 for 171. Nope, I did it wrong. What did I do? 171. That says 130. H of 10. 3 times 10 is 30 plus 1. Fine. H of 10 minus g of 10. H 30 plus 1. That's 31 minus g of 10. G of 10. 10 squared is 100. 10 squared, opposite negative, plus 1, 99. Those are adding and subtracting. That's minus 68. I think that they have a problem. They made a mistake. 171 says 130. I don't see 130. So I don't know where they get 130 from. Unless it's very obvious. And they haven't been wrong before. So what am I not seeing? H, 3 times A, 3 times 10 is 30, plus 1 is 31. 10 squared is 100, man. I think it's negative 68. Oh, I found it. Minus, I see my mistake, minus the g of 10. Mr. Mac made a mistake of thinking that negative was my negative in 99. It's minus the g of 10, which is, so we get 31 plus 99, and that gives you 130. They were right. I was wrong. How hard, you can see, I'm such a try-hard on trying to make them make a mistake. No, g, 2 times negative 7 plus 3, negative 14 plus 3 is negative 11. G of negative 7 is negative 11 minus, we're not going to make that mistake again, kids, h of negative 7 equals 2 times negative 7 plus 1, which is negative 14 plus 1, which is negative 13, minus there, so we didn't make that mistake this time, and that gives us 2 for 172. We got it correct. 173, we got 17 problems still to do. G of 5, so G of 5 equals 2 times 5 plus 1, which is 10 plus 1, which is 11, times, that's kind of cool, H of 5, which gives you 3 times 5 plus 3, which is 15 plus 3, which is 18. So 11 times 18 is 198. How'd you know how to do that fast? Because I know how to multiply by 11s. 198. We're good. My arm hurts. G of 5 equals 4 times 5 minus 4. 20 minus 4 is 16. So 16 times h of 5, which equals 5 cubed minus 5 times 5 squared, which is 5 cubed, so h of 5 is going to equal 0. 16 times 0 is 0. That's a little quick. Did you figure that out? That'll save you some time. So were you the smart kid who understood that one? F of 1 equals 2 times 1 to the third plus 5 times 1, which is 2 times 1 plus 5, which is 2 plus 5, which is 7. F of 1, 7 divided by g of 1. G of 1 equals 1 plus 3, which is 4. So g of 1 equals 4. 7 divided by 4, which is 7/4. Can I get that as a fraction? Yes. Thank you for not making it a decimal. Can we see the bottom yet? Oh, I'm one off of seeing the bottom. H of negative 10. So h of negative 10 equals 3 times negative 10 minus 3, which is negative 30 minus 3 is negative 33. Negative 33, that was a horrible 3. Negative 33 divided by g of negative 10. Okay, g of negative 10, which equals the opposite of my n value squared minus 4 times my n value. That is negative 100, because negative 10 squared is 100. Bring down the negative. Plus 40 is negative 60. Negative divided by a negative, so that's negative 33 over negative 60 makes positive. 3 goes in that, 11. 3 goes into that, 20. Positive 11, 20. Yep. Okay, we can see the bottom. We can see it. G of x, when x, okay, so g of x is just going to be that, negative x minus 4 plus h of x, which is the quantity negative 2x squared minus 2x. Distributing that positive doesn't change anything, so that just becomes that. We're going to put it in standard form, and we're going to combine like terms, which is negative 3x minus 4. I don't think we have to factor. Pretty sure you can just leave it like that. Yeah, I knew they were going to distribute. You're going to have to distribute. So g of x is x squared plus 5x minus the h of x, which is 2x plus 5. So we get x squared plus, well, oh my, I don't know what the heck happened there. Whoa, I'm pushing too many. All right, let's start backing things up. Sorry. X squared, I guess I must be hitting the buttons with my wrist. 5x. Let's distribute that negative, which is negative 2x minus 5. X squared, like terms, plus 3x minus 5. 178. It's getting dark in my house because it is 7:26, and I'm on my dining room table. It is dark. All I can see is the screen, and I just want to be done. Oh, you know what I do see? A big mosquito. I hope that's outside. I think it's inside. Okay, keep going. H of x. Oh my. 4x minus 2 times g of x, 3x squared plus 1. We're going to FOIL. First is 12x to the third. Outer is plus 4x. Inner is negative 6x. Last is negative 2. Nope, I made a mistake. 12x to the third. 4x. This is negative 6x squared. That's negative 2. So 12x to the third minus 6x squared plus 4x minus 2 would be my answer. And the reason why I'm saying I can't see is because I'm trying to check the answer key. I hope that big mosquito doesn't come over by me. G of x divided x to the third plus 5x divided by x plus 5. We are doing long division. No, we can factor out an x. Yes, we are doing long division. Oh my goodness. Or are they just going to do this? Let's see. Indicated operation. Oh, imagine if we had to do long division. 180. 180. No, they leave it like that. Okay, you don't have to do long division. You got lucky. State the excluded values. Excluded are the values that make this 0. Exclusions, just you can't have a variable equaling, so my excluded value is -1. My excluded value is +9, because that would make 0. My excluded value is 0. Oh, the lights on the porch went off. My excluded value is 0. That's the only value that makes x, that you can plug in for x would make it 0. So that's how that's working. Let's look for the excluded values here. It's still 0. It's still, oh no, it's simplify, sorry, simplify. But those are excluded. We will need to know that. I don't think the other ones were simplify. No, just state the exclude value. Now we have to simplify. So we're good with this. This is, you're going to deal with the coefficients first. So 7 goes into 70 10 times. 7 goes into 21 3 times. V, well, look, you got one V here, you got two V's here. Let's be smart and just understand that there's going to be a leftover V there, and my excluded value is 0. I think, sorry, they say, this is how they do excluded values. They say x cannot equal 0. That's what it looks like. Let's look at 85. 10 over 3v, and, oh, okay. It's not, oh, v, and it's not x. Technically, that's not a bad thing to say v cannot equal 0. Let's simplify this. What goes into 70 and 30 is 10. 10 goes into 70 7 times. 10 goes into 33 times. So you have x to the fourth over x to the fourth. That's going to cancel. And excluded value, x cannot equal 0. Okay, that's kind of new for you. 2 pages left. So we're going to factor this. So we have 6 over, we can factor out a 3, and you get 2a plus 9. And we see that we can cancel this. So a 3 goes in that. So 3 goes into 6 2 times. 3 goes into 3 cancels. And you have 2a plus 9. These 2's cannot cancel. Lots of students are going to want to cancel that and write 1 over a plus 9. But this is your simplified value, and your exclusion, you can sort of think of it as 2a plus 9 equals 0. So you subtract 9 and divide by 2. So your excluded value, x cannot equal -9/2. That's your excluded. 187 -9/2. Yeah, same thing. So we're going to factor a 2 out. We get x plus 9 over x plus 9. These cancel. These cancel. You're left with 2 as your simplification, but your exclusion, because we have this, x cannot equal -9, because -9 would make that 0. So that's your number 88. We're going to factor this numerator. I'm going to expect that you can factor, you can mental factor. Factors are going to be +9 and -4. Factor this, we can factor out a 9. You get x plus 9. These, k plus 9. These will cancel. You're left with k minus 4 over 9. And your excluded value is -9 is your excluded value. We can factor that. That's going to be p 6 minus 6, p plus 2. This is going to be p minus 9, p plus 2. These p plus 2's will cancel. You're left with p minus 6 over p minus 9. The p's can't cancel, the 6 and the 9, even though we have a common factors because they're adding and subtracting. And then our exclusions are negative 2 and positive 9. So we look at both of them. What would make that 0? What would make that 0? Kids, we're done. We did it. Let's go with the new tablet in my house. Congratulations. Good luck tomorrow. I'll talk to you on Monday, see how it was. Also, remember to share with me what stuff was on there that we maybe didn't cover. Good luck.